Hello，大家晚上好。We are OnCallOps. AI reception is already becoming a commodity in Australia. You can get 24/7 AI answering from around $49 a month. But that's not what we are selling. What we are building is the operating layer behind the call. It turns missed calls into safety screened, capacity packed bookings, keeps urgent work visible until someone explicitly takes over and leaves an audit trail behind every material decision. Imagine this. It's after hours. Water is coming into a tenant's kitchen. The plumber is already on another job, and the caller cannot wait until morning. For a small plumbing business, that missed call could be the urgent job. Our target customer is a licensed plumbing business with around 3 to 15 people. Their technicians are out on site. Admin support may be limited and the calls come in spikes. OnCallOps answers the call, gets consent, captures the facts, evaluates safety risk, operational priority, and the relevant New South Wales context separately. Then either books eligible work or escalates it until a person explicitly takes over. Now, there are already a good AI receptionist products for tradies in Australia. They can answer calls, book jobs, triage emergencies, transfer to a non-uncle plumber, and send SMS message and sync information into existing systems. That's the entry ticket. It's not the product. The gap is how the outcome is controlled and proved. OnCallOps makes booking guards, acknowledgement state, rule versions, and failed cases visible. A summary tells us what happened. A decision trace shows which inputs, rules, and side effects produces the outcome. So the gap is not answering the phone, it's controlling and providing the outcome. And that is where OnCallOps sits. We are 9 people, one delivery team. We don't use permanent squads or fixed module assignments. People claim small vertical slice tickets, and each epic has a temporary epic owner responsible for acceptance and integration. Work is owned by outcome. For next part, I will hand it over to Zoe.
Thanks, Emily. Here's our proposed solution. We categorize it into 3 simple controls. First of all, the AI never makes the safety call by itself. It just listens and pulls out the facts. So what is wrong, where, and how urgent. Separately, a fixed rule book decides what happens next. So the risky decision is never left to the guest. It's a rule we can point to. Secondly, the same system is accountable for different states and different rules. So New South Wales and Victoria have different legal requirements for calls like this. Instead of rebuilding the platform for each one, we just switch the settings. And last but not least, we test it like a real safety system. We use golden calls, which is a set of scripted test scenarios, to run through it automatically every time we make a change. So we know it's always catching the critical ones, not just hoping it does. So in short, the AI listens, the rule decides, and we can always show our work. Next slide, please. So in terms of the workflow, every call the system handle ends up going down one of the 4 clear paths. Path A, if it's urgent, like a burst pipe, we grab the details and connect the caller straight to the on-call technician with a text message as backup. Path B, if it's a routine like a checkup booking, we know the job and preferred time, but we never pretend to confirm an appointment. Path C, if it's a real safety risk like a gas leak or electrical fault, AI never tells the caller how to fix anything. Instead, the system reads out a fixed, pre-approved safety warning, escalates it immediately, and logs everything. Path D, if it's not actually our job, like if it's a council water main issue, we tell the caller who to contact instead. We never try to make that work for ourselves. So no matter what the call is, it will never fall through the cracks. Next slide, please. To trace back how each decision has been made from and the source, here's the data structure. Every customer has their own settings, which includes their state, service area, on-call number. Every phone call is logged against that customer, and every call that turns into a job is logged too, with how urgent it was and what happened next. But the important part is that what sits underneath all of that is for every single decision the system makes, we save exactly why, which rule fired, what fact it sought, and what action it took. That's what let us answer why did it do that a month later. And one thing we deliberately don't keep is the actual audio recording. No raw audio is stored ever. That's partly a legal call. So recording consent rules are different in every Australian state. So the simplest way to stay safe is just to not record in the first place. Only the minimum text is kept, and even if that expires after 30 days. So for the next part, I will hand over to Ho.
Thank you, Tori. So here is the entire call in one sentence. Studio receives the call, deep current transcribed, GPT-5 extracted the intent and the facts. Deterministic rule engine decide how serious it is and what to do. ElevenLabs speak the reply and everything is written down along with the decision trees. The important thing on this diagram is where the rule engine sits. So it is on the main path rather than off to one side. The model's job stops at extraction, and the decision itself is a pure function with no network calls and no randomness. So the same input always reproduces the same output. This is why we can stamp a rule set version onto every call record and reproduce that decision weeks later, which is something a prompt can never give you. The obvious question is why we are not using a single speech-to-speech model, because that would be faster. The answer is that the speech-to-speech absorbed the text layer into module, and the text layer is exact what we are selling. Cascaded also gives us something we need for evaluation, because every hop is a sim we can mock and measure. We pay for that choice in latency, so we budget rather than estimate. The table on the screen gives every hop its own target. The one worth pointing out is the rule engine, which is measured in single-digit milliseconds because it's pure memory with nothing to wait for. Underneath that, you can see what production stacks of the shape actually achieved today. We are not claiming to beat it, but that's the bar we will measure against, and we will report the real numbers even if we miss. So here's the tech stack. So one concern, one deliberate tool. The 4 boxes on the screen are the whole stack, so I'm not going to read them out. What matters is that Python handles the real-time call, and the AI workflow, TypeScript handles the dashboard, and the types between them are generated from one shared schema so that the sim cannot silently drift. The row underneath the box matters more than the boxes. Redis, salary, vector search, and the rest of the all deliberately deferred. We know what each of them does. Each of them are also added something to run and something to debug, with no real pay for inside a build this sort. So we added them on evidence rather than habit, and the condition that will trigger each one is already written down. So this is the UI. The dashboard and audit interface rather than a call log. On the left is the job list. The person on call at midnight only needs 3 things from it: how serious the job is, whether the transfer was answered, and where it stands on. Color carries the severity, because at midnight nobody reads a table. On the right is the panel nobody else has. Every competitor produces a call summary, and a summary answers what happened. But this is written by the same module that made the decision. So this is the module granting its own work. This is decision trace, and it answers why. You can see the rule that fired, the section of the act behind it, how confident we are in each fact we extract, the safety crypt we played, and the version of the rule table at the moment. So nothing in the panel is written by the module. All of it come out of the rule engine. That difference is the whole product. So for data, everything on this page is aligned in the data module or a config file, rather than a paragraph in a policy document. The one I would point at first is that there is no recording table. Raw audio is processed in memory and then thrown away. And that is a design decision rather than a missing feature. The 3 points beside it follow the same idea. Transcript expire on a timer. Personal information is masked before it can reach a log. And the new transparency rules for automated decisions are something we are already building against ahead of the data they take effect. The panel on the right is the part worth of a moment. Recording consent in Australia is not a rule. It varies by state, and some states need every party to agree, while others need only one. So we made the state a config file. Everything that changes between judges lives in a one file. From whether we need consent before we transcript, through what we can do if the caller says no, to how long anything is kept. Adding a new state means writing one of these files. It is not a code change and it is not a prompt change. One thing I want to prescribe about is that we say this is designed against this requirement. We do not say it is compliant because that word needs a legal review we have never known. And next part, I will hand it to Jim.
Thank you, Paul. This slide shows what is scope and what we cut on purpose. We keep safety rules, jurisdictions switching between New South Wales and Victoria, and the decision trace to every code. We defer vector search, multi-tenancy, and speech-to-speech. It's for a clear reason. Every code protects our core, safety, structure, and evidence. Next page. This is our 12-week plan, with one measurable milestone every Friday. And we build a skeleton, then a mock code, then added the live phone line and safety rules. By week 6, replay testing is complete, and next week's harden the system and go live and run integration tests. The final week's free staging, rehearse with the team, then demo on the 5th of November. This shows how our team is organized into 4 squads. Voice pipeline handles the phone call itself. Rules and safety own the decision logic. Data and dashboard stores and shows the evidence. Eval and delivery handles testing and deployment. These 4 squads meet as 6 shared contracts, so each squad can build independently in parallel without breaking each other's work. And next part, I will hand it over to Karina.
Thanks, Jim. Next, I will walk you through our success metrics. This is our plan for how we will prove the system works and how we will test it. We will test on 30 calls. 12 are high risk, 18 are normal. Every test runs automatically every time we change the code. We have 4 targets. First one is task completion. It needs to be at least 80%. Second one is safety recall must be 100%. So, which means every high-risk call must trigger the safety response every time with no exceptions. Third one, false positive rate will stay under 10%. This will stop the AI from crying wolf on normal calls and pushing customers to turn it off. And last one, field accuracy, at least 90% across name, address, problem type, time, and phone number. The report at the bottom is a sample. It shows the format that our result will take. Next, I will show you the risk we have identified. We already have a plan for each one. Our rule is simple. If we miss a target, we write it down. We don't lower the safety bar quietly. So first one, getting an Australian phone number can take time. We will order it early and keep a backup number ready. Second one, Australian accent and street names sometimes are hard for voice recognition. So we will read every address back to the caller to confirm it, and fall back to the phone keypad if we need to.
Third one is a wrong safety script would be dangerous. So 2 people will review every script and we will test each one before it goes live. Next risk is we may not hit our speed target on the first try. So we will measure the real number and report it. Then we can find a solution to improve it. Last one, the AI might try to give repair advice it shouldn't give. So we will have a filter to check every response. So that's all our plan for the risks. Plumbing is our first industry tag, but it won't be the end of our product. What we are building is a reusable core, the layer that makes the next voice workflow safe to ship. Plumbing industry will prove our idea works, and the platform will make the next industry safe to add without starting over. So that's all for our proposal. Thanks for listening. Any questions?